Hi, my name is Ron. This video is meant to be an extension or a part 2 of a previous video that I recorded called The Danger of Vaping Nickel Wire. And so I invite you to watch that video first before you watch this one. In that video I lay out a number of the basic concerns I have about the use of nickel as a heating element inside of the atomizer of a vaporizer. So first, I do want to say overall that vaping and vapor products will be and should be regarded as one of the greatest technological innovations of the 21st century. I think that these products have the potential to completely eliminate smoking in our homes and our communities. And that's just fantastic. I mean, these products will be regarded as one of the greatest advancements in harm reduction that we have maybe ever seen with regard to smoking. However, it is important to know and to recognize that all vaping products are not the same. So this is a basic vapor pen. This is not the same as this. It's a much different type of device. The way they are used in both form and function are very, very different. And so the devices are very, very different. The way it's used is different. And so when we're looking at harm reduction, I think it is a little naive to think that every single vaping product in the wide range of vaping products will reduce harm to the same level. They are different. And I think with respect to the use of nickel and nickel wire, this comes into play. It may not be reducing harm to the same level as everything else because all vapor products are not the same. One of the common things that people look at is the melting point and boiling point of nickel, and saying that because it has such a high melting point and boiling point, it is therefore safe to be used inside of a vaporizer. Now, the melting point of nickel is 2,651 degrees, and the boiling point is 2,730 degrees. No, you probably would never reach those high temperatures inside of a vaporizer. Now, if you dry burn any coils, so in other words, if you don't put wicking material and e-juice into an atomizer, and if you just dry burn the coil so it's red hot and glowing, that will easily reach 1,000 degrees or more. Will it reach the melting point or boiling point? I don't know. I mean, some of these devices I've seen people demonstrate, and if you heat it enough, you will see breakdown of the metal. Now, what does this mean, the melting point and boiling point? Why is it important in our discussion of nickel? I think people misunderstand that metals, anything really, will react as it is being heated. It is not like the melting point and boiling point is not like a safe level and you're okay to use something up until that. If you've ever boiled a pot of water, and I know this is an exact analogy, but if you boil a pot of water, steam comes off before it boils. So you're heating it and it will begin to steam before it reaches its boiling point. And so I think, you need to recognize that things can react and break down, especially metals and really anything, as it is being heated. The other temperature that comes up when discussion of Ni200 is 600 degrees. Now, 600 degrees is the limit for most devices when they're doing heating and temperature control. What is 600 degrees? Why is that picked? Ni200 has a industrial usage temperature recommendation of 600 degrees. So you're only supposed to be using Ni200 in industrial usage up to 600 degrees. Ni200 was never designed to be used inside of vaporizers for direct lung inhalation. So it's used in industrial usage. It's used in the manufacturing of chemicals and electrical industries. It is used in the manufacture of soap. It's used in the aerospace industry to make missiles. So if you're making a missile, you're not supposed to be using Ni200 for anything that is beyond 600 degrees Fahrenheit. It does not mean that it is safe to use it in a vaporizer up to 600 degrees. When you're looking at metals, mass actually matters quite a bit. So a large piece of metal may be reacting differently to heat than a little tiny wire, like the Ni200 wires that are used inside of vaporizers. So as the Ni200, as the nickel wire is being heated up, things could be happening inside of the vaporizer. It could be leaching, it could be breaking down, and it's certainly possible at lower temperatures and at these wattage levels that we're putting them through. Again, there's very little research on this, and no manufacturers have shown it to be safe. And I think it is very important that we look at manufacturer responsibility in the use and development and promotion of these products. So let's look at some of the features that show up in these devices and discuss what they mean for our use and discussion of nickel inside of a vaporizer. Now, one of the features that has been showing up is a nickel purity setting, where in the device you can actually dial in a purity setting for the nickel that you're using inside of the vaporizer. I don't know if people know what the purity of the nickel that they're using is. It's kind of an unusual thing. It brought up some interesting questions, though. Now, I think the idea is that I think the nickel in the United States apparently is pure, but there may be areas of the world where the nickel is not, that they're using inside of their vaporizer. And this, I guess, the manufacturers discovered, and they're trying to make the temperature readings more accurate, because you have to understand that a temperature-controlled device does not actually measure temperature. What it measures is changes in resistance in the wire, which is why nickel is used in the first place. It has very, very low resistance and is very, very susceptible to heat, and so the resistance changes predictably, and so the device is able to figure out the temperature. My understanding is that the temperature readings are generally accurate, but again, it's also an area up for discussion. Again, the devices are not actually reading temperature. But I think because they're reading resistance, they discovered that impure nickel maybe gives a less accurate reading. And this brings up an interesting thought, I think. When we're looking at something like this, nickel purity, what research has been done? And it made me rethink a previous statement that I made, that no research had been done by the manufacturers in relation to nickel. Maybe research has been done, and it just hasn't been released. If they began to question the purity of the nickel, what else were they testing? Have they tested the vapor? Have they, what were they looking for? Why did this even come up? And this is not the first time in history that we've seen manufacturers do scientific testing on products and not release results because maybe it runs afoul of their business model. And we need to actually recognize that it is possible that research has been done on nickel, but it just has not been released. And we have a right to see it. We have a right to know. So I mentioned the 600 degrees earlier as the limit set for industrial usage of Ni200 wire. There are some devices, however, that you can actually do temperature control beyond that 600 degree Fahrenheit limit. Specifically, the Sigeli 75 watt and the Asmodus Snowwolf 200 watt can actually allow the user to do temperature control up to 662 degrees Fahrenheit. There's another device called the Homewrecker Mod by an American company called HomeTech, although the device is made in China. This device can do temperature control up to 700 degrees Fahrenheit. So this is 100 degrees beyond the suggested limit for the use of Ni200 in industrial usage. So, why? Why are these devices allowing the users to go beyond what we would consider a safe usage for Ni200 in industrial usage, let alone something that's used for direct lung inhalation as part of a vaporizer? And I think this really goes to manufacturer responsibility. The manufacturers have a responsibility to make safe products, and not only to make safe products, but to also show people how to use them, to have usage directions when they sell these devices. It's not enough just to show how to press the buttons and what happens on the screen. They should actually be showing people how to use them. For example, this is the instruction manual for the IPv4 from a Chinese company called Pioneer for You. This is it. This is what you get when you buy the device. There is almost nothing on it. Very, very little. They show you how to use the screen. They show you how to put the batteries in, although they don't even tell you what kind of batteries to put into it. This is the instruction manual for my wall phone. And this is just the English version. There's a whole nother one that's in Spanish and a whole nother one in French. And it gives you everything you're going to need to know about the use of the wall phone. This is the instruction manual for a microwave oven. It is 26 pages of fully illustrations about how to use the microwave oven, but also usage instructions. In other words, how to cook food in the microwave oven. So this type of thing for a vaporizer, quite frankly, is ridiculous. There needs to be more information given to users, not just how to press the buttons, but also how to use the device, how to make the coils, what kind of tanks to use on it, and that kind of thing. People should not be confused in how to use these devices. Again, it's manufacturer responsibility to show people how to safely use the devices that they're putting out. Something that has also shown up in these devices that I think is very troubling and concerning is that some of the devices have been reported to be slipping out or falling out of temperature control mode. This really, quite frankly, is very, very dangerous. Nickel wire is non-resistance wire, and it relies on the temperature control to give any type of safety in using the device. Now, if it slips out of temperature control, you would be putting full power, direct power, through a non-resistance wire. And that wire, you could be getting, you're going to get a whole big mouthful of nasty is what you're going to get. And that is really unacceptable. The devices need to be manufactured properly, and they should never be slipping out of temperature control. Why are they slipping out of temperature control? I've seen a number of reports based, maybe it's the way the coil is sitting inside of the atomizer. For people that do RBAs or rebuildable atomizers, the coil has to be made just right. It needs to be secure. If it's not, maybe that's what causes it. Sometimes a low resistance, if it's reading low resistance, that will cause it to slip out of temperature control. I've seen reports of it slipping out, though, with manufactured coils from the manufacturer. Now, this really classifies the device as dangerous. It has to really do with manufacturer's responsibility to make a safe device and have really good quality control when they're making these devices. The other thing that comes up with temperature control is, how do you know the temperature readings are accurate? Remember, these devices don't actually read temperature. So, like, if, this is not a temperature control device, but there's nothing inside of the atomizer. You can put any tank, if you build a nickel coil, or any RDA, or rebuildable dripping atomizer, or RTA, rebuildable tank atomizer, onto a temperature control device if you have nickel, and you can run it in temperature control. But the tanks or atomizers do not have any thermostats in them. They're not actually reading temperature. They're reading changes in resistance. And you're really relying on the device to give you accurate readings. Now, like I said before, I do think the readings, from what I understand, are pretty accurate. But how do you know? I've seen people discuss these devices, and oftentimes people think that they're not accurate, that they may be as much as 100 degrees off when doing temperature control. Again, the manufacturers really need to show that these things are safe. They need to have maybe demonstrations with thermal heat detectors showing that if it says 400 degrees on the screen, you actually are getting 400 degrees in the atomizer. That hotspots are being accounted for in the atomizing coils inside of the vaporizers. And right now, we have no manufacturer showing that any of this stuff is being manufactured, that quality control is there, and that it's safe to be using. So I'd like to have a few final thoughts. I understand that people are very passionate about their vaping devices, but the way I look at it is that these things are mass-produced consumer electronics, most of them made overseas by people in conditions that we have very, very little knowledge of. And so we need to evaluate them based on them being mass-produced consumer electronics. They are not religious artifacts, and though people are very, very passionate about what they're using, I think we need to kind of take a step back and take a look at them, evaluate them, and see if they're really something that's safe for people to be using. Personally, I believe that the use of Ni200 nickel wire inside of an atomizer was a mistake. I think they picked the wrong metal. And I am actually looking forward to new devices that are able to accurately read temperature, maybe having some sort of temperature sensor inside of the atomizer, so you can use a wire like Canthal, which is resistance wire, a very tolerant metal, whose resistance does not change at different heat temperatures. But I think overall, everybody needs to make their own estimated, educated determination of risk and safety. And we need to use the information we have available to determine what's right for us. No manufacturers in the United States or in China at this point have released any studies that's showing that nickel or any of the temperature control is really, really safe to be using. And again, the manufacturers really have to step up and do that. What do we know about nickel? Well, we know that nickel is toxic. We know that nickel is highly carcinogenic if you get it in your lungs. We know that the Environmental Protection Agency in the United States classifies nickel as an environmental pollutant, and they put it on their list of extremely hazardous substances. So given that, I think that manufacturers need to step up. They need to show that they've done study on this and that the devices are working properly and that they're being manufactured very, very well. Putting out a new product every week is simply not important. What is important is that the manufacturers put out good and safe products that people know how to use with good instructions. And going forward, as this industry matures, I think that is when it's going to make the products better and make the industry much stronger. Thank you.